Good evening, ladies and gentlemen. Thank you very much for giving me a voice. I will be talking today on nanocellulose preparation, basing on an article written by Professor Giannis Panoglu from Thessaloniki in Greece. The work is entitled Techno-Economic Consideration of Nanocellulose Future Progress, a short review. Nanocellulose is quite natural material coming from natural components with special producible properties and more renewable character in case of using the present strategy. Both technical and economical aspects you were talking and develop possible potential scenario for key performance and indicators and selling price of nanocellulose. Nanocellulose is organic derived as though from cellulose, so from lignocellulose, then is separated to cellulose, the appearing in organ in plants and plants waste, and these three are characteristic of nanocellulose. Nanofibers, those consisting long and thin fibers with high aspect ratio, are excellent for reinforcement agent in composite as a thickening agent in coatings and adhesives. Nano type is nanocrystalline cellulose, which are small and rod-shaped with high crystallinity and strength-to-weight ratio, are used for high-performance metals and composites, so similar but not thickening. Bacterial microbial nanocellulose, which is produced by bacteria and have high degree crystallinity, unique three-dimensional network structure, is useful for biomedical and other similar pharmacy application. Microfiber related, not nanofiber, is considered as similar to nanofiber as reinforcement, but lower price and lower better for end using. With poor characteristic, but less strength than nanofibers. Materials for engineering and electronics. The mostly common raw materials are wood chips, cornway, husk, wheat straw, and sugar paste, as also sulfur residues and agar and cotton. Cases will be some technological mechanical treatment for each sources and disintegrating them for particles. The method is predicted to nanofiber cellulose. However, nanocrystalline can be also made by mechanical treatment of cellulose fibers. In this case of mechanical treatment, nanocrystalline particles vary in size and shape. Therefore, it's not very useful, such useful, because hard to predict the the monosize. So we need to separate size or leave in unseparated. This is the trouble. It is also nano separated in biochemical treatment, which gives much more mono size and is have higher purity and well-defined properties because are mono size and only size and can be used as used under smart harsh chemicals that could be energy intensive, so energy requirements, which is the trouble that chemicals requires much energy in production. Thus, also in result, nanocrystalline is high energy consuming process. There are other methods like electrospinning, epoxidation, enzymatic hydrolysis, ultrasonification, ionic liquid treatment, plasma, and use. Uh, Final choice is to decrease properties of nanocellulose. Nanocellulose properties from probably most remarkable that is a large surface to volume ratio, high mechanical strength despite low weight, optical properties including high transparency and birefringence, electrical properties including high dielectric constant and piezoelectricity, biocompatibility and biodegradability, so can be easily after waste use the decompose and use sustainability due to its natural origin and renewable character, so similar to to renewability and therefore we have cellulose for Canada's. That is the biggest industrial using for nanofibers, using for adhesive and composite. In Canada, over is filial, which produce microfiber cellulose for paper waste. Other is BioPlus that used for nano cellulose used for packaging and composite. There is also Finnish coming nanocells for forestry waste. There are some examples. The record was used as in 2021 as $320 million and in 8 years becomes for 3 times higher, so 1 billion of dollars, and the largest markets will be as usual in North America and Europe. They don't think the Asia would be such interesting, but I think that researchers are not convincing. The situation is using higher technology levels, so using to scaling up the different nanocellulose production identified as use. And first is lignocellulose waste, tracked alkali treatment reactor, filtration, bleaching, filtration, and residue, which is not fully, is returned to bleaching reactor. Similar to nanocellulose by drum layer and mechanical production mixture, and first by only milling, and other one scenario one and is requiring acid by sulfuric acid denaturalization and membrane ultrafiltration, which is which is more corrosive but much more efficient in certain case. So alkali treatment therefore and requires less strength materials is similar, smartly cheaper, but the efficiency is much higher in case of sulfuric treatment. And this is the triable how to compare to divide or use another acid and drying and washed. And similarly, economics says that production volume can be used in case of acidic even 2000 tons per year in case of reactor of 500 liters. The section is using is now cellulose from different cost. In case of one, if is mixed, and scenario 3 using acid is production is mostly useful, but in case they can say that in bigger capacity, the more efficient would be using hydroxide treatment for efficiency. So in case of building plant capacity of 5,000, the better would be using the mixed hydroxide mechanical is the most suitable. And this shows the importance of using and cost. The cost of fat acidic is the lowest, and quite waste treatment costs are low, but much bigger is working capital, and this is the trouble. In first scenario, second scenario, which is Mrs. Dias, is the highest efficiency. So the highest cost in acidic is two times higher, times cheaper than in case of mixed mechanical and hydroxide treatment, basic treatment, and slightly less than only hydroxide treatment. So we see that we can use the capital cost from equipment would be used. So in specific water consumption, so in this overall is the acidic is the most useful, if not requiring, if we omit requirements of high prices of steel of materials for vessels. So the corrosivity is also so fine in case of, but requirements for high basic character is also useful, and this is the trouble. So this is using the how nut source can be produced and how important would be as components and strength material and electronics, and how important is to design proper life cycle assessment. Thank you very much for listening to me.